Solve the following initial value problem. Express the solution in terms of a convolution integral. So we have the ODE where alpha is unknown and y at 0 equals 0, y prime at 0 equals 1. These are two initial conditions. We first take Laplace transform of this ODE. Take Laplace of the ODE, then Laplace of y double prime plus 4 Laplace of y, because Laplace is linear, so we can distribute in this way, equals Laplace of cosine alpha t. Now using the table we can find Laplace of y double prime is s square Laplace of y minus s y 0 minus y prime 0. Okay, that's first part, plus 4 times ly, just ly. We did not need this bracket, equals Laplace of cosine alpha t. Laplace of cosine alpha t, we don't have to take Laplace of this, because even if we take Laplace later we have to take inverse Laplace and it's going to be the same thing, and we are not finding the answer in full form. We are writing the solution in terms of a convolution integral, so I would leave just Laplace of cosine alpha t in the right instead of finding the Laplace of cosine alpha t. We could have written, but I just want to leave like this. And let's use the initial conditions. y0 is 0, so this is 0, y prime 0 is 1, and from these two we factor L of y out, so s is squared plus 4 Laplace of y, this is negative 1, move that over, so that becomes plus 1, so 1 plus Laplace of cosine alpha t. Now divide by this to isolate Laplace of y, so Laplace of y is 1 divided by this, so 1 over s squared plus 4 plus Laplace of cosine alpha t divided by s squared plus 4. Okay, then y of t will be, take the inverse Laplace of right hand side, so this is inverse Laplace of first plus inverse Laplace of this. So let me write in this way, this is Laplace of cosine alpha t times 1 over s squared plus 4. Okay, and let's do this in two parts. We know the Laplace of sine t. Okay, Laplace of sine t is given by sine t is 1 over s squared plus 1. If sine at, if we have sine at, a over s squared plus a squared, so this is 2 squared, so we need 2 on the top, so why don't we multiply by 2 and divide by 2. Okay, so this is a over s squared plus a squared, then inverse Laplace will be 1/2 sine at, so sine 2t, plus same thing here, we are missing 2, so we multiply by 1/2. Okay, multiply by 1/2 and 2 there. Okay, so 1/2 outside, Laplace inverse of Laplace of cosine alpha t times, this is Laplace of sine 2t, and this big. Now this part is good, 1/2 sine 2t plus 1/2. Now we are taking the inverse Laplace of product of Laplaces, and by the convolution theorem, let me write over here, when we have f s times, let's say, gs, where f and g are the Laplace of lowercase f and g, f t star gt. Okay, we know the Laplace of f convolution g is fs times gs. That means inverse Laplace of this is just convolution of f and g. So inverse Laplace of these two things are convolution of alpha cosine alpha times convolution of cosine alpha and sine 2t. So this will be using the convolution, the inverse Laplace of these two things will be cosine alpha t convolute sine 2t. And the question wants us to leave the answer in terms of convolution integral. So let's write what is that. So 1/2 sine 2t plus 1/2. From the definition of convolution, this is 0 to t first function alpha t minus v. So we got here cosine alpha t minus v times sine 2v dv. Okay, that's the answer, that's the y function, and this is definite integral in terms of 0 from 0 through t. So when we evaluate, this would be a function of t final.